In this video, we're going to be talking about slope. Now, what is slope? So for a linear graph, or a linear equation, a slope is the measure of how steep the graph is. Okay, so we're going to be seeing some graphs. And as the one on the left, you notice how the line, as I go left to right, it's not really going that high very fast. So that one actually has a smaller slope. But likewise, if it goes left to right, it's really steep. That's going to have a large slope. So it's kind of like if you're skiing, if you're going up a hill or down a hill, if it's very steep, we call that a big slope. If not very steep, then it's not a very large slope. And slope is actually given by a number, so slope actually has a measurement. And we'll learn how to come up with slope for linear graph. And I think I kind of said this earlier. If the graph of a linear equation is going down, I'm looking at it from left to right. Okay, I didn't talk about this. As in this case, it's going down, going from left to right. It will be negative. My slope will be negative. So this linear graph has a negative slope. If it is going up, as I'm going left to right, as the right equation is, that's going to have a positive slope. So think about if you're going left to right, am I going downhill? Am I going uphill? That'll give me a negative slope or a positive slope. So how do you find slope? Well, step one is to pick two coordinates on the line. In some of the problems that I'm going to give you, they'll actually give you 2 points, as we have some right here and right here that we can choose from. Okay, so let's use those 2 coordinates. Start on the left point and find the rise and the run to get to the other point. So you're going to kind of make a step on it. Start with the left point. So let's start with this one. And think about how far up do I go? I got to go up 1, 2, 3, 4 boxes there, or 4 distance. And then I go to the right. So we go up or down and then go to the right. So we went up 4 and over 1, 2, 3, 4, 5. So 1, 2, 3, 4, and 5. So we'll always kind of make a step out of it. Now slope is rise over run. So once you find out how far up or down you go and how far to the right you go, just put those numbers in, plug them in like a fraction. So we went up 4. I went up, so it's positive. And I went down, or over 5. So 4 over 5 is my slope, that line. Now, one quick thing to say about slope is, okay, we have 4 over 5. You know, it's kind of like a fraction. If we can break down that fraction, go ahead and do it. 4 over 5 can't break down anymore, so we'll just leave that as is. Going on to a few more examples. Let's take a look at the left graph. And we have our points here. Let's start on the left one. So for this, we're going up 1, 2, 3, 4, over 1, 2, 3. There's 4, there's 3. Again, it's rise over run, or how far you go up or down, and then to the right. So I went up 4 and over 3. So 4 over 3, and that can't simplify down. I can't break that down. Can't divide anything out of the top and bottom. So just leave it as 4/3. The next graph here, I go up 1, 2, 3, and then over 1, 2, 3. So up 3, over 3. So 3 over 3. You can kind of think about that a couple different ways. You can think of it as 3 divided by 3, or just simplifying 3 over 3. But in any way, that should give you a 1. So this one actually has a slope of 1. Next one here, start on the left point, so we're going up 1, 2, 3, 4, 5, and over 1. So 5 over 1, but 5 divided by 1 just gives me a 5. So we can't have a slope as just a regular integer and not a fraction. For this one, start on the left point, we'll go up 1 over 1, 2, up 1 over 2. I got a slope of 1/2, rise over run. A few more out. Again, start on the leftmost point. We're going to go up 1, 2, over 1, 2, 3, 4. So 2 over 4. And that'll simplify into 1/2. as a fraction. Next one here, I'm going to go up 1, 2, 3, 4 over 1. So 4 over 1 from my slope, and 4 divided by 1 will give me 4. So we looked at some graphs where we had positive slope, and now we're going to talk about ones that have negative slope. So you notice how these, as we go left to right on the graph, they go down. So these are going to have negative slope. So again, we're going to start at the leftmost point, at that dot. We're going to go down 1, 2, 3, and over 1, 2, 3, 4. So down 3 over 4. Now when you go down, that's going to make the slope negative. So right away, let's put a little negative. And then we went down 3, and then over 4. So the only real difference on these is we're going to put a negative in front. For this one, we're going to go down 1, 2, 3, over 1, 2. So down 3, and then over 2. So it's still going up or down on top, and then going to the right on the bottom. A few more. We go down 1, 2, 3, 4, and then over 1, 2. So down 4, and then over 2. 4 over 2 can simplify. 4 divided by 2 just gives me 2, so that'd be a negative 2 for that one. Next one here, I'm going down 1, 2, 3, 4, 5, 6, and then over 1. So minus 6, and then over 1, or just a negative 6 for that slope. So trying a few more out. Start at this point. We're going to go down 1, 2, 3, 4 over 1, 2, 3. So negative 4 over 3. And that can't break down, so we will leave that as is. Next one here, go down 1, 2, 3, 4, 5, 6, 7, and over 1. So minus 7 over 1, or just say negative 7 for that slope. Now these ones that have dots on them, if you ever see a line that actually doesn't have these dots, you can still do this the same way. You just have to pick a couple points on the graph. And which I have the next ones here. And these ones don't have those nice dots. So what you're going to do is look at the graph and find points on the line that go through exact coordinates. Like for this one, there's a point that goes through 0, negative 3 exactly, so we're going to choose that for a point. And there's a point that goes through 3, negative 1. So we're going to use those two. Now you could have used this point down here and then use these 2 points. It'll give you the same slope, so it doesn't really matter what you use. You could have used the outside ones. It would have given you the same slope when you simplified. So it really doesn't matter which ones you use. But just for this one, I'm going to use the middle point and the right point. So again, make a step out of it. I'm going up 1, 2, and then over 1, 2, 3. Up 2 over 3. So 2 over 3 is my slope for that line. You would have gotten the same slope out of these 2 points as well, up 2 over 3. So you can kind of see how slope gives you kind of a step pattern. So next one here, let's find some points that'll work. You can use this one. This one will work. This one will also work. So points on the graph that go through very precise points. You want to be kind of picky about that. Again, it doesn't really matter which one you use. Let's use this one and this one. We're going to go down 1, 2, 3, and over 1. So 3 and a 1. So that would be a negative 3 over 1, or just a negative 3 for a slope. Again, you could have used these 2 points here, would have given you the same slope. So just a few examples on ones that don't give you those dots. So a few of them that look a little strange. So these are 2 examples that you're going to see, and they actually won't have a positive or negative slope. So anytime you see a line that is straight horizontal, like this one, or straight vertical, these ones are special. So anytime you see a line like this, it's just straight horizontal, that actually has a slope of 0. So you're not going up or down at all. It's kind of like you're walking on a straight path or hill or whatever. There's no hills at all. It's just a straight line. So there's no way to actually measure how steep it is if I'm going up or down. So I'm just going straight, that's 0. And going up or down, this one is undefined. So it's so steep, and it's really the most steep it could possibly be. It's just a straight wall. It has an undefined slope. So the last problem that I'm going to talk about in this video is finding slope from 2 points. So let's say that you didn't have a graph, but they just gave you 2 coordinates. We're going to today, or at the end of the video here, find out how to do that. So we're going to use this equation. So we have a nice equation that we're going to use, our formula. And it is y2 minus y1 over x2 minus x1. So basically it's just saying the y value of the second point minus the y value of the first point divided by the x value of the second point minus the x value of the first point. So let's take a look at an example. And rewrite the formula up here. So we got y2 minus y1 over x2 minus x1. So that is our formula for slope between 2 points. And the first thing that I want you guys to do is just label the coordinates. So we have 2 coordinates here. What I want you to do is just call one of them x1, y1, and one of them x2, y2. So it's an x value and y value of the first point, and an x value and y value of the second point. And now we're just going to plug in the numbers right into the formula. So if you start off looking at the formula, notice at the top we got y2 minus y1. Well, which one is y2? We designated y2 as 6. So 6 minus y1, but y1 is 4. So 6 minus 4 divided by x2 minus x1. So x2 is 30 and x1 is 25. Right. So on the top we have 6 minus 4, which will give me 2, and then 30 minus 25 will give me 5. So 2 over 5 for a slope on that one. Now you actually could have went the other way. You could have called the second point x1, y1, and the first point x2, y2. It would have given you the same answer, and I'm just going to show you that quick, just to show that it really doesn't matter which one you use. So now flipping them around using the formula. So if you want to just forget what I say right here, then that's fine. If how I did it the first way made sense. But this is just another way to do it. Maybe you want to do it this way for some reason. So y2 minus y1. y2 is now 4, and then minus 6 over x2 minus x1. So 25 minus 30. So it just kind of switches the numbers around. 4 minus 6 gives me a negative 2. 25 minus 30 gives me a negative 5. But since I have a negative on top and bottom, those are going to cancel out. So 2 over 5 is still my answer. So just showing that however you label the coordinates, it doesn't matter. But what I don't want you to do, so here's not what you're going to do. You're not going to do this. So don't label this one x1, x2. We don't want to do that. It's got to be x2, y2, or x1, y1. Just like that. So let's take a look at a few more examples. So again, we have the formula y2 minus y1 over x2 minus x1. So just label one of them x1, y1, doesn't matter. I like to do the, whoops, and I almost just did what I told you not to do. X1, y1, and then x2, y2. So it doesn't matter which one you identify as the first one or the second one. So y2 minus y1, so 4 minus 2, over 6 minus 5. 4 minus 2 will give me a 2. 6 minus 5 will give me a 1. 2 over 1, I can break that down. That just gives me a 2. So identify one of them as the first point, x1, y1, x2, y2. So y2 minus y1, 40 minus 10, over x2 minus x1, 25 minus 15. So 40 minus 10 will give me 30. 25 minus 15 will give me 10. 30 divided by 10 will give me 3. Next one here. Throwing in some negatives. So here is x1, y1. Here is x2, y2. Y2 minus y1, so 19 minus 5 over x2 minus x1, so negative 3. Now when you're subtracting negative numbers, so x2 minus x1, but x1 is negative 4. So you actually have two negatives there. And when you're subtracting a negative, it's the same thing as adding. So anytime you see two negative signs with each other, just think of that as a positive sign. So 19 minus 5 will give me 14 on top. Negative 3 plus a 4 will give me a 1. So 14 divided by 1 will give me 14. So for this one, let's designate one of them x1, y1. One of them x2, y2. So y2 minus y1, 7 minus 5 over x2 minus x1, so 0 minus a negative 1. So 7 minus 5 on top will give me 2. 0 minus a negative 1, or adding a 1, will give me a 1. 2 divided by 1 will give me 2. First slope for that one. This one here, let's change it up. Let's call the second coordinate x1, y1. And the first one x2, y2. So it doesn't matter which one you designate the first one or the second one. So y2 minus y1, so negative 11 minus 6 over x2 minus x1, so 4 minus 3. So negative 11 minus 6, that'll give me a negative 17. And then 4 minus 3 will give me a 1. So we have negative 17 divided by 1, which is just a negative 17 for a slope. This one here, x1, y1, x2, y2. One of the points, y2 minus y1, so 5 minus 5 over x2 minus x1, 8 minus 5. So on the top, 5 minus 5 will give me a 0, and the bottom I have 3. 0 divided by 3 is still just 0, so that has a slope of 0. So you notice how they have the same y value, so they'll, when you graph it, both of the points will lie on the y equals 5 line, so that gives me that horizontal line that we discussed earlier. And the last one I'm going to discuss, x1, y1, x2, y2. So y2 minus y1, so negative 3 minus a negative 5, divided by x2 minus x1, so 6 minus 6. So negative 3 plus 5 will give me a 2, and dividing by 0. So we got a little trouble here. Dividing by 0, can't divide by 0, so this one is actually undefined. So cannot divide by 0. So you notice how they have the same x values, so they'll lie on the x equals 6 line, a line that is straight up and down. So that has an undefined slope that we talked about.